Good morning, students. So today is, today we're going to go over the reactions of precipitation and solubility. Okay, so for this reaction, we went over the general rules of it. So precipitation reactions are processes in which an insoluble solid called a precipitant forms when reactants are combined in an aqueous solution. So in this one, more than anything, what's going to happen is you're going to have two aqueous solutions. So you can see here, they are both clear liquids before mixing them together. And then once you mix them together, they are going to make something that is called a precipitant. So it's going to be a solid. Okay. So on this one, the main thing that we're really worried about is solubility, because solubility is going to tell us um, the amount of compound that will dissolve in a given amount of solvent at a given temperature. So solubility is going to be the most important part to be able to tell if something is going to be a liquid or if it's going to become a solid. Okay, so if a substance has a low solubility, then it is likely to precipitate from an aqueous solution. If a substance has a high solubility in water, then no precipitant will form. Okay, so basically, low solubility means it's going to become a solid. Okay, and then high solubility means it's going to stay an aqueous solution. So to be able to know what the solubility is, we mostly go off of this chart, which is called the solubility table. So this is going to be something important to understand. This chart will be given to you on the exam, so you don't have to memorize it, but you do have to know how to use it. So on here, it has the soluble ions. So these ones are the most soluble ions. They dissolve almost all the time. Okay, they only have few exceptions. So that's why on this table, we only have the exceptions. So this first one is for the group 1 ions. Okay, group 1 ions are going to be everything in column 1. So it's going to be hydrogen, um, sodium, lithium, potassium, and everything in that column. So these ones, no matter what anion they are bound to, they will always be soluble. So let's think of some examples. So NaCl. Okay, so Na is going to be one of the group 1 ions. And then it's bound to Cl, but no matter what it's bound to, it's going to be soluble. So this one is always going to be aqueous. Okay, let's think of a lithium example. So Li, and we're going to give it Br, LiBr. So lithium, again, group 1 metal. So even though it's bound to a halogen, so this one's going to be soluble. And when something's soluble, we give it Aq. Okay, so that's how we're going to interpret this first part. So any group 1 ions are always going to be soluble. Okay, next group. So in this one, we have the polyatomic ions. So on here, there are only 4 of them. So it's ammonium, nitrate, acetate, and perchlorate. So these ones, just like the group ones, are always going to be soluble, no matter what they're bound to. Okay, so an example is going to be NH4 is ammonium. So if I bind that to Cl, okay, so this one, because we have Na4, we see that on the table. Na4 has no exceptions, always soluble. We give it that Aq. Okay, it's always soluble. Another example is going to be, let's do perchlorate. So perchlorate is ClO4. Okay, and let's put Mg on there. Okay, Mg. So, first of all, we know that perchlorate has a charge of -1, Mg has +2. So don't forget, we do have to have 2 molecules of ClO4. Anyways, so for solubility, we see that this one's here. This one has no exception. So this one is always going to be aqueous. So for those four polyatomic ions, no matter what they are bound to, they are always going to be aqueous. Now, hal halides or halogens. Okay, these ones. Now let's look at how they dissolve, or if they dissolve with other atoms. So these three dissolve with almost everything. Okay, so as we saw above, NaCl, soluble. We also saw LiBr. LiBr is also soluble. However, when you bind it to any of these three, all of a sudden it becomes insoluble. So if I put AgCl, instead of that usual AQ that we have, now it's a solid. Okay, another example, AgBr. Okay, and for Br, we'd have two of them to balance out that charge. This one would also have that parentheses S because it's a solid. Okay, and then last group is going to be the sulfate. Okay, for sulfate, this one, it's almost always soluble except when bound to these four atoms. So if I have SrSO4, this one's going to be a solid. If I have PbSO4, this one's also going to be a solid. Okay, so if I had, let's say I have CaSO4. Okay, so this molecule, we check on here, okay, this one's typically soluble, except with these four exceptions. Ca is not one of those exceptions, so this one is going to be aqueous. Okay, so that's how we're going to use this chart. We're just going to see what the exceptions are, and if we have those exceptions, then it's going to be, or sorry, if we don't have any exceptions, it's going to be soluble. If it does go with one of the exceptions, then it's insoluble and will make a solid. If it's not on this table at all, it'll be a solid. Okay, so let's go through some examples. Okay, the first one is NH4NO3. So let's see if we have those on our table. So as we see here, I have ammonium right here. So that's ammonia. And then I also have nitrate. So I have both of them. Okay, we look at the exceptions. This one has no exceptions. So this one is going to be soluble. So AQ. Okay, so that means soluble. And that means it's going to be a liquid. It's going to be aqueous. Okay, now let's look at the second one. I have LiOH. So OH, I don't see that anywhere on the table, but I see right here. And this one has no exceptions. So this one is also going to be AQ. Or we can say it's soluble. Okay, aqueous soluble. So next one, PbCl2. So for Cl, we look at the halides, okay, that Cl is there, and we look at the exceptions. So we have the exception here. And so since this is one of the exceptions, okay, so we'll put exception. Okay, so it means that halide is typically soluble except when it's with one of those three. So this one is going to be a solid. Okay, also known as insoluble. Okay, solid. Oh my gosh, solid or insoluble. Okay, last one, FeOH. So Fe, I don't see it anywhere on this table. And I don't see OH on here either. So because it's not on the table, it is a solid. Okay, so that's how you're going to use this table to be able to tell if something is soluble or insoluble. Okay, so next I would have you practice on the worksheet. So try out section 4 of the worksheet of chemical equations. And we're going to keep going to the next section. Okay, so for precipitation reactions and solubility guidelines, for these reactions, you will switch which cation is bound to the anion. Okay, so basically, sometimes we're going to ask you to be able to predict the products, which isn't something that you've done before. So these reactions are a little bit simpler on how to tell what's going to happen than other ones. And so the way you do it is you look at what is there and you have them switch which atom they're bound to. So on here, I have AgNO3 as one of the molecules, and I have NaCl. So if you look at these, Ag is going to be our cation, NO3 is going to be our polyatomic ion, but it's also an anion, okay, because it has that negative charge. Okay, Na, cation. We can tell because it's a metal, Cl is going to be our anion. So because of that, we know that Ag cannot be bound to Na. Okay, if I have AgNa, then I have a positive charge bound to a positive charge. And there's no way to balance out that charge. So those two cannot bind together. And just like that, NO3 and Cl would have two negative charges together, so those would not bind together. There'd be nothing to balance them out. So what we do instead is we have the cations bind to the anions that they weren't bound to before. Oops. Na. There we go. NO3. Okay. So it's exactly what we're going to do. We're going to switch them to the opposite or to the other cation and anion. And that's how we're going to predict the products. Okay. And you're just going to have them swap which atom they're bound to. Okay. But now let's write some steps on how to write reactants and products. Okay. First things first, you're going to note down which ones are the cations. Okay. You're going to note down which ones are the anions. Okay. And then you're going to swap them. So as you can see here, Ag and Cl are now together. Okay, so that's the first step. First step is to write down what atoms are now bound to each other. Second step is to determine if the ionic compound is soluble. Okay, so before we use the solubility table to see if something's soluble or not, and we have to keep doing the same. Luckily for the reactants, they gave us that they are aqueous. But for the products, we have to figure that out. So for this first one, AgCl, we know that's a halide because that's Cl, and we have Ag here. So Ag is an exception, thus this is going to be a solid. Okay, NaNO3. So we actually have both of these on the table, and both of them have no exception. So this is going to stay aqueous. Okay, so step one, predict the products, have them swap from cation to anion. And then second step is to see if they're soluble or insoluble. Okay. And then, so let's practice one more time. Okay. Will a precipitation reaction occur when an aqueous solution of CdCl and NH4 are mixed? Okay, so on here, I'm first going to notate which ones are cations. Okay, so cation, anion, cation, anion. Okay, so now using that, I can predict which ones are going to go together. So Cd was with Cl, so now I'm going to swap it to S plus, okay, so NH4 used to be with S or sulfur, now will be with Cl. Okay, and then one thing that we a little bit skipped over last time was balancing those charges. Because as you see now, we made a new molecule, so we have to make sure that they have a sorry, a balanced charge of 0. So let's make sure that we do that. So CD, I'm not super sure what the charge is on this one. So if I'm not sure, one way we can look at it to figure it out is we can go to the reactant side. So on the reactant side, I have CD bound to Cl. And I know this is a neutral compound because there is no charge on it. So using the negative charge on here, I have -1 on each of those Cl's. So in total, it's a -2 charge. So CD, to be able to balance that, has to have a +2 charge. Okay, and then each atom, or these atoms, are going to have the same charge on the reactants and the product side. So CD is a +2. Sulfur is on column number 6, so this one's going to be -2. So this one is balanced, 1 to 1. Now for ammonia, okay, ammonium we know is a +1, just because we memorized our polyatomics, and chlorine is a -1. So these both don't need any additional atoms to be able to balance them. They are already balanced. So we got lucky on that. Okay. But now next thing we need to do is we need to see if they're soluble or not. So CDS, let's see, neither of those are on our solubility table. So what we're going to do is we're going to put it as a solid. It's not on the table, it's a solid. Okay. Now on this one, I have NH4. And so NH4 is on the table right here. So we can see that there are no exceptions, so it's always aqueous. So aqueous. And now we have our predicted products. Okay, so make sure to go through those steps. Make sure to first predict the products by swapping these. Okay. Second, balance out those charges. See if you need to add any more. Okay. And then last step is to check solubility. And also, we forgot to check solubility over here. So let's do that real quick. This one is going to be aqueous. Okay, we know that because NH4 is still not soluble with anything. And then CL. So Cl right here doesn't have an exception of CD. So this one's aqueous. Okay, good. And that's going to be our solubility rules. Okay, so I want you to try out this example by yourself. Oh, actually, nope, that's the same example. Okay, awesome. So now go to the worksheet and practice with those questions again. Okay. And then let me know if you guys have any questions and I will answer them in class.